Good morning everyone. Bonjour à vous tous et à vous toutes. Bon matin, my name is David Brulotte, and I was introduced. I'm the Delegate General of Quebec here in the Western United States. It's an honor to be here this morning with you all, and it's an honor to be moderating this panel about the future of manufacturing here at the Phoenix Global Forum. Now, Arizona is a perfect place to be having that conversation, obviously, given its position as a hub, as was mentioned this morning, most notably about Mayor Gallego, a hub in advanced manufacturing and just the phenomenal fast-paced growth that the region is experiencing. Now, everything currently happening about manufacturing is obviously very exciting, of course, but it comes with challenges, and it comes with opportunities around sustainability, security, resilience. We've heard about supply chain, friendshoring, nearshoring, and this is what we're going to talk about with our very distinguished panelists today. But before I introduce them in a moment, I'd like to briefly let you know about what's happening in the province of Quebec. And I'm echoing the words of Mayor Gallego this morning, referring to Phoenix as a retirement community that's way past beyond this and now. And I'm sure if I mention the province of Quebec, you may all think about snow, the French language, maple syrup, and Celine Dion. But obviously, we're also very much past that stereotype, especially when it comes to aerospace, sustainable mobility, and electronics. Not only many of the technologies developed back home in Quebec are complementary to what's happening here in the US, but we're also very focused on sustainability. Some of you may or may not know that electricity in Quebec is 99% green. It's produced by hydroelectricity. So whatever is produced in Quebec, either through services or products, can be integrated in supply chains here in the US, and it's all green. You can also work on R&D with companies here to develop less carbon-intensive processes and materials. Now, a little over a month ago, the Quebec Minister for International Relations was here in Phoenix and signed a declaration of intent with Governor Hobbs, Governor of Arizona, to strengthen the relationship, both political and economic ties between Quebec and Arizona. It's my message today to all of you to let you know that Quebec is really open for business. President Biden was actually in Canada in March of last year, and he referred to the Canadian hub for the North American semiconductor corridor, about a region called Brulotte, just south of Montreal, which is a lovely region. Region is already host to the #1 independent pure-play MEMS factory in the world at Teledyne DALSA. It's also the largest semiconductor packaging facility in North America at IBM. IBM also has the only quantum computer in Canada in the same region. And just last week, the government of Canada, and I say hi to my colleagues from the Consulate General here, as well as the government of Quebec, announced a $225 million reinvestment in an expansion project in Brulotte. So ready to invest, work with Arizonian companies that are here with the state and, of course, with the United States to achieve our common goals. Now, I'll invite our panelists to shortly come on stage. As you know, this is a very highly distinguished panel. Their bios are extremely impressive, so I would invite all of our distinguished audience to read their bios online. I won't go through all of them. They'll be able to introduce themselves in just a second. So first, I'll invite Barbara Humpton, who's the president and CEO of Siemens Corporation, to join me on stage. Then Kirby, founder and CEO of Bespoke Manufacturing Company. Todd Brady, Chief Sustainable Officer and Vice President of Community Relations and Sustainable Operations at Intel Corp. And Jason Child, Executive Vice President and CFO of Harm. Please join me on stage. Thank you all. Thank you. As I mentioned, our panelists have both very impressive careers, backgrounds, and work for some of the largest, most advanced manufacturing companies in the world. So I'd like for you to introduce yourselves, perhaps a little bit about your company. And Barbara, if I may ask you to go first.
I'd
please.
be delighted.
Yes.
Siemens is a focused technology company. We are working on technologies where the real and the digital world come together. And today you'll see us working in rail. You might have seen the announcement we're the preferred bidder for high-speed rail on the West Coast. Between LA and Las Vegas. But we also are working in fields like buildings and the edge of the grid, as well as the transformation of manufacturing with both software and hardware that are now coming together with new capabilities that I know we're shortly going to be able to get into. But think about this 175 plus year old startup that is focusing on the ever emerging technologies that are changing our world.
Thank you. Kirby?
Great. I'm Kirby Best, and I run two companies. The first one is Bespoke Manufacturing, and we specialize in high-end women's wear. So I'm not even a rounding error in these guys' books. But the second company is called iCreate.fashion, and it is the system that runs these factories and takes the information from the wonderful creative people in the design world and translates them into manufacturable instructions that are machine readable and human readable. So.
Thank you, Kirby. Todd?
Yeah, good morning and welcome to Arizona. I've been here in Arizona for 30 years. I'm with Intel Corporation. We're one of the world's largest semiconductor manufacturers, so we both design and manufacture semiconductors. And the reason, of course, that's critical is our world is digital and runs on semiconductors. So we're super excited. Just down the road, if you get a chance, come visit us. We've got 4 state-of-the-art fabs with 2 more under construction. Great to be with you this morning.
Hello, my name is Jason Child. I'm CFO of ARM, and ARM is probably a company that you may not know. We actually are not in manufacturing, but we are very much in chip design. The company was actually founded over 30 years ago as a joint partnership with Apple and then with a company called VLSI, which is now part of NXP. And really what has transpired is we actually, this partnership was created to build the first handheld computer, the Newton, which probably most people don't know other than maybe as a doorstop or whatever, but it wasn't really that successful. It did eventually become an iPod and eventually an iPhone. And then of course it became a smartphone. And so we're now in about 99% of smartphones. We actually design the chips that were, because of that focus on a battery powered device, we're very efficient, and we're focused on low power compute capability. And so our designs are one of the most prevalent technologies in the world. We design chips that are now in about 280 billion chips that have been shipped and are in pretty much every single industry today.
Thank you, Jason. Now, let's jump right in and talk about the first theme of this panel, innovation. And we've heard this morning about, as Goldie referred to, friendshoring, nearshoring, or Team North America, as he prefers. Emilio mentioned, similar Canada, US, Mexico friendship. My question is, how do you see innovation in your companies playing a role in securing that North American leadership in advanced manufacturing? And maybe talk about some of the steps your companies are taking to achieve this.
Would you like to start with me?
Please.
Let me jump in because Siemens has been focusing our business around global megatrends, working on climate change, urbanization, the aging demographics of people everywhere, the ever-increasing global supply chain, and the digitalization of everything. Well, those last 2 things actually have brought us to a new megatrend, globalization. What if we could move data, not stuff? What if we could de-risk supply chains because we could make almost anything anywhere? The digital tools now exist for us to capture designs, transport them, and enable makers to bring those things to life in the real world. We believe this is going to be absolutely vital to globalization and is going to be strengthening everything we have, everything that we could possibly need, we have in the Americas. And that is going to position the Americas for strong security and resilience.
Thank you. Perhaps Kirby?
Oh, I love what you said, because that's right up our alley. So we do believe that the creative sources around the world will create their products and be able to use the internet to ship them to the market that they want to manufacture them in to be as efficient as possible. I came out of the book industry, and we really changed that industry dramatically. The publishers were publishing large quantities of books, and then 35% of all the hardcover books were being thrown out, and 55% of the softcover books were being thrown out. So the inefficiencies were enormous, and we created this one-off book manufacturing, and nobody knows about it, but it's behind the scenes. If you buy a book on Amazon today, if you buy it before 6 o'clock tonight, we'll print it and bind it and ship it to you by 4:30 the next morning. And it's just changed the way the industry's looked. doing business. And so now we've moved into the garment business, and we're trying to do the same thing there. And we're innovating every day on how to do it better and faster, cheaper. So.
Thank you. Todd, perhaps an Intel?
Yeah. So I mean, innovation, two great examples and really critical across all industry today. To innovate, the world's changing so quickly, and probably no better proof point than the semiconductor industry and silicon and the silicon economy, of which we're all a part of. Our economy runs on semiconductors and silicon. And I think probably, as many of you know, one of our founders was Gordon Moore, who coined Moore's Law, which was the observation that the number of transistors on a chip double roughly every couple of years. And in recent years, we've accelerated that even further. We are achieving 5 nodes in 4 years. Each node is a reduction in the size of the transistor that's on a semiconductor. A typical semiconductor may be the size of your thumbnail or fingernail. And on that device today, we can put over 1 billion transistors, if you can even fathom that. These are things that are just at the atomic level, these transistors turning on and off 1 billion times per second. And there's 1 billion of these turning on and off over 1 billion times a second. The numbers just become overwhelming, but that's the innovation that's required in order to create something like that. So this is a topic that's near and dear to my heart, near and dear to Intel and the entire industry and all of us here on stage.
I would say from our perspective, we are very much on the design side thinking about, how can we significantly reduce the power requirements that are required really for all devices. That is really the DNA of the company. As I mentioned, we were birthed out of this desire to have a handheld battery device, which up until then didn't really exist. And so that DNA has now actually found its way into, server technology, or even into cars, or even into edge devices and cameras and security devices, et cetera. And so our focus is, because of the power constraints, I imagine we're going to talk about the power constraints, which are not easing. Our focus very much is on providing every single year double-digit productivity and efficiency as to what we can get from the power compute needs for all the different chips that are increasingly powering the world.
And if I may just jump on that comment, how do you see this into the leadership that North America is hopefully getting through what you're designing? Maybe a reference to what's happening here on our soil here.
Sure. So there's actually, one of the challenges I think right now is there's certainly been focus how the vast majority of the most complex chips are basically manufactured in one region of the world today, and that's not in the U.S. And so I think there's a huge benefit for the U.S., but also the world, to increase diversity in where manufacturing is occurring. And it certainly, I think there's some obvious benefits for the U.S. And so there's been a lot of work, and we've worked pretty closely with Intel and a number of other partners to really try to help with the CHIPS Act as one kind of specific example, where we're now significantly increasing capability. And so we're just one small piece of it, but I think there's a pretty significant momentum that's occurred over just really the last 2 years.
Great.
Yeah, and if I could put a finer point on that, if that's okay. If you go back 50 years when the transistor was first invented for silicon and chips and whatnot, obviously that was done here in the U.S. in Silicon Valley, and at one time we had the dominant share of manufacturing semiconductors was all done here in the U.S. And over time that's eroded till today. About 80% of chips are manufactured in Asia, and then a little over 10% here, and even less in Europe. And so what we have stated, our goal is to rebalance that. Such that by 2030, to achieve more parity, half and half the chips being manufactured in Asia, and then the other half between the U.S. and Europe. And so I think the reason that became crystal clear, I think, for everyone was during the pandemic, when all of a sudden you couldn't even buy a washing machine or, an automobile, and it was because of a chip that cost, $1, $2, and it brought the whole supply chain to a halt. Mm-hmm. And so I think by having that geographically dispersed supply chain and manufacturing capability is critical going forward.
Yeah, and let's build on this because let's think about the ecosystem that leads to the ability to localize. One reason that manufacturing has been concentrated in single points is because we've been doing labor arbitrage. Mm-hmm. Well, what if the technologies in manufacturing today could make every worker more productive? So that labor differential becomes less and less in the overall economic equation. Now add to that the risk decisions, et cetera. Now we have reasons to be making everywhere and it's affordable. So look for automation, not to be one of those things where everybody says, whoa, it's coming to take my job. No, it's coming to enable people to be more productive so that we can rebalance supply chains.
And Barbara, I'm going to jump on this for a second, but how do you ensure, especially in your corporations, that the workforce sees this as a benefit? How do you equip them? How do you train them to make sure that the new technologies that you work on, that you're bringing on board as well, sort of reassuring and more productive for them?
Yeah, and I'm so lucky to work for a large corporation. Here's a corporation with 300,000 employees globally. We've got some 50,000 across the United States. And therefore, we've got resources internally to be able to provide some things. One is that digital transformation. And so what we've been looking for is employees who have two characteristics: curiosity and initiative. Mm-hmm. Because things are moving so fast, you've got to be able to know, what needs to be learned, and you got to take the initiative to go learn it and put it into practice. So we're teeing up those transformational tools. The other thing we're doing is bringing digital natives into the manufacturing environment, working side by side with 40-year veterans of manufacturing, so that, people can start to, the new people can learn from the experts, but those experts can learn how to apply new tools. And I really think multi-generational teams are going to be a key to us making this transition.
That's great to hear. Kirby, I'm going to skip over just for a second because I have a bit of that conversation yesterday, and I'll come back to you in just a short second with another question. I'm curious to have a word from Intel and from you, Jason, at ARM about your workforce training.
Yeah, workforce development is critical for us. The skills that we see that we need in the future absolutely requires investment. And to build on what Barbara was saying, one of the areas that we see a need in is getting interest in children at a young age to go into engineering and math and science. And so we've launched a number of different programs at the K through 12 level as well. One of them that I'm particularly fond of is called AI for Youth. So introducing youth K through 12 students to what is AI, what can you do with it, what can become of it, and not just targeting maybe a traditional demographic, but how do we expand so that we're getting everyone involved and ensuring that we're targeting a diverse workforce and we're bringing in talent from everywhere across the spectrum. And so that's been a big focus for us as Intel, and I think I know many other companies are doing the same, but it's going to be critical as we look ahead to where are we going and what do we need, that we have a very talented and educated workforce in this area.
Thank you.
Yeah, I don't want to restate. We are doing some of the similar efforts. I think one of the things that's really interesting that we're spending a lot of time thinking about is how the education and needs of our future employees are changing very, very rapidly. So for example, we have about 8,000 employees, so quite small compared to Siemens, for example, or Intel. But about a little over 7,000 of them are actually engineers. And at least a few thousand of them are software engineers. Well, typically you would say, well, then you really got to go focus on STEM and so on and so forth. Now, with the prevalence of AI, they're actually now starting to say maybe kids shouldn't go learn coding. They need to instead focus more on what are you building? And you're actually going to use AI to do a lot of the actual coding, which is a pretty big shift from where we've been for the last 20 years. So I'd say we're trying to stay nimble on trying to understand exactly how things are moving and how do we make sure we're training our employees and helping them stay relevant, but then also focusing on what the future needs will be.
That's great. And Kirby, I'll come back to you for a conversation we've had yesterday. Yeah, obviously, all of your companies are, by default, very digitally advanced, very modern in that sense. Kirby, you've recently implemented a new technology a fleet of autonomous mobile robots in your operations. Can you speak to the benefits that you've seen from this?
Sure. Let me go back a step, just to put things into reality, why we need chips that are so powerful. We launched a line of bridesmaids dresses recently, 3100 West. By the end of Q2, we will have 2,929,000 quadrillion SKUs available in these dresses.
Quadrillion.
Quadrillion. I had to get ChatGPT to figure that out. But it shows the model is shifting so much. And David, to answer your question, is that you have to take the product once it's come off the cutters, and it has to go to all the sewers, and it has to go to the sewers at the right time, at exactly the right time in the right place. And so we deployed this fleet of AMRs that pick up the cut pieces and then query the system, and it goes through 5 quick questions. What pod do you want to go to? So it'll say, I want to go to the side seam pod. And it'll say, what machine do you need? And it'll say, I need a single needle machine. And it'll say, well, we have 25 working in that pod today. What color thread do you need? And it'll say, I need black thread. And go, well, of the 25, 5 are working on black thread. And it'll say, okay, of the 5 working on black thread, who is qualified to do this product? And it'll say, well, Janie is qualified, and Susie is qualified, and Sam is qualified. And it'll say, how can I get through them the fastest? And it'll go, well, Janie has 7 totes in front of her, and Sue has 5 totes, and Sam has 2. So it'll say, take me to Sam. Now this query goes on 6 times a second as the robot is moving through the plant. So people often ask me, did I buy robots to replace people? And it was, I didn't actually have any thought of replacing people, because we're a greenfield operation, but because no human could possibly make those decisions, keep track of those decisions, record those decisions for the analysis. So that's, we've had a lot of luck with it, and it's pretty exciting to see a factory that takes old world skills of still putting 2 pieces of fabric through a sewing machine, but everything else is automated and everything is scalable. So.
It's fascinating. I invite you to have a look at the Bespoke manufacturing's website, so you see what that looks like in action. Kirby was Bespoke. Sorry, apologies for this. Kirby was referring yesterday when the robots actually sort of collide with one another and apologize to one another as a Canadian traffic jam, which I thought was very interesting. Kirby being also Canadian, so we share that as well. Now, we've talked about the very sort of positive aspects to all of this. Any challenges that have been, sort of critical into implementing those technologies in your companies that you're trying to overcome?
For me, yes, lots. That it's new, that the workforce fears that it's going to take their positions away. We overcame that in about 3 months. They were worried about collisions, not just the robots hitting each other, but hitting humans. And so far, we've never had a collision. So it took a while to understand it. We still have staff that have trouble grasping the complexity of where it has to go at what time and believing in the system. And that would probably be my biggest issue is the kind of if something goes wrong, they just want to go back to doing it manually like they've done it for 100 years. And we go, no, believe in the system. And it always comes through. So.
Fascinating. Thank you. Maybe challenges you've seen at Intel trying to shift, procedures, implement new technologies?
Well, it's incredibly challenging, as I was saying, to get down to the scale at which we're operating. But it has been interesting in my career. I've been with Intel almost 30 years now, and I remember going into the factories 30 years ago when I first started. And, technicians everywhere operating all the equipment, very manual, moving of everything. You go in our factories today and you just see wafers. So you go into a clean room. So maybe I'll take a step back. To manufacture a semiconductor, you have to have a clean room. And the clean room is 10,000 times cleaner than, say, an operating room. The idea is you remove all the particles out of the air so that there's no contamination that ends up on the wafer. And so you go into these clean rooms, which are these massive ballrooms, 5 football fields in size with all of this equipment. And these wafers are carried in pods, and they are moving rapidly around the ceiling, going from piece of equipment to piece of equipment, because there are hundreds of steps to make that tiny device, which is the semiconductor. Well, all of that is now automated. All of that is being controlled remotely, actually next door, where there's a remote operation center, and they're keeping track of everything that's going on within the factory. Now, having said that, we still need technicians. In fact, we need more today than we did back then in many applications, because they are focused on preventive maintenance, troubleshooting issues, working all of these things. And so the skill level is being elevated, but the jobs and opportunities are still there. So one of the biggest challenges is exactly that. How do we continue to feed that pipeline of talent, as we talked about, for these new skills that are continuing to come forward, which require more and more understanding and training and education?
Jason, maybe at ARM?
I guess we're lucky in that we don't have the manufacturing and implementation challenges. That said, since we're on the design side, we're typically focused on the next 3 to 5 years. And each of our partners are pushing us pretty hard on what the expectations and requirements are. What's fascinating right now is you look at certainly AI. We went probably a record length in this discussion before mentioning the term AI. I think it was like at least 8, 9
I'm coming
minutes.
to it. Don't worry.
And it's fascinating, the power requirements. And I think anyone who's really dug into it will say it really has to have compute, and it's got to have power. And unfortunately, as you need more compute, and the compute gets more intensive. If you look at some of these recent LLMs, they're exponential in terms of their power consumption. Then you're going to need more power. And so we're constantly being pushed on. You've got double-digit efficiency is great. We need more, and it's got to be more and more and more. And so what's fascinating is right now you look at like even data centers, for example, which is where a lot of the discussion about NVIDIA, for example, all the GPU stuff, that's a data center use case. So today we're at about 2.5% of the power consumption in the US. Expectation in the next couple of years is that goes to 7.5%. So that triples. It's got to come from somewhere. And there isn't a lot of excess power kind of not being used right now. So just to kind of demonstrate how critical that constraint is, we actually talked to the conference organizer, and they're going to shut off the AC for the rest of the day and tonight, just so everyone can feel like it and really. No, I'm sorry, it's not really that funny. Anyways, but no, it's so that is what we're constantly dealing with. I think it's just starting to become known in the public realm, but the constraints. It's definitely becoming a real concern that's going to go beyond just how do you get more efficient from the design side. How do you also deal with transmission and generation, and not to mention sustainability aspects? It's definitely just starting to get, I think, a lot of discussion, and probably will get more.
Thank you. And perhaps, Barbara, if I may ask you to comment on this?
Yeah. And again, I keep coming back to how interrelated all of this is. Just a quick comment that we rely on Intel for the very chips that will go into the automation equipment that we'll be providing to manufacturers who will consume electricity, which we will actually make the switchgear that goes into the grid. But here's what's amazing. Because of the new technologies we have, because of having software-enabled hardware now, we've got smarter components going in everywhere. And so what I see is a virtuous cycle where, and maybe this will be the segue into this whole topic of sustainability, because if we know that our future depends on the amount of electricity our grid can produce, then we can actually design for sustainability up front. We have the software tools that will help decision makers. Just as you move materials around a shop floor, You can move design elements around. 80% of an item's sustainable footprint is determined in the design phase. And so design for sustainability, design for power use, we now have tools to help us accomplish all of that. The big thing we have to all be focused on is what is the system we exist in so that we can make judicious decisions that are going to be fruitful for the whole system so that we don't end up being the victims of our own success.
That's fascinating, and I'll come back to it in a second. And it is indeed a perfect segue to the second part of our panel about sustainability. So second topic. So let's shift gears a little bit and move on to this. Again, question for all of our panelists here. And you've mentioned imperatives that are set by regulators and decision makers. But in the business realm, how do you set your sustainability goals and deal with this compared to the business objectives of obviously being profitable and the competitiveness imperatives that you all face? So let's maybe start with Barbara.
Yeah. And let me just set this up as do not buy the false choice. Sustainability is efficient. Sustainability is profitable. I mean, what is the cost of doing nothing? The problem with today's financial systems is that they aren't taking into account the long-term effects of what we're going to be dealing with as a planet. If we could do that, what we would clearly see is that the smart decisions right now are the more sustainable decisions. And by the way, today, as I keep mentioning, the digital tools that bring us greater sustainability choices also make us more productive and more efficient. So what I keep getting excited about is the double, the triple whammy. You know, we can build in a plan for making a business more productive, for making it more local, for making it more sustainable. And that's the exciting thing about the moment we're in.
Thank you. Maybe I'll jump to Jason at ARM just to mix things up a little bit.
I think, from a sustainability standpoint, clearly, I think we have our own, of course, specific goals as a company. I mean, honestly, for us, our carbon footprint is mostly tied to traveling around the globe because, we're pretty diverse globally. But most of the discussion actually comes with partnering with all of the different, key partners we have in the ecosystem and how are we going to basically generate this significant, compute savings. I do love the comment that the software is absolutely critical. I think, I'm generally probably a bit of an AI optimist, not just because it certainly benefits our business, but I think also because the efficiency you get with great software and figuring out which workloads can be done way more effectively and efficiently and how you make sure you reduce off-peak and utilization or improve utilization, et cetera, is so much waste in the system. And so really our focus is really, I think, in partnership. We've, a couple, I think the Jensen from NVIDIA and I heard the folks at Google kind of refer to ARM as like water because we're kind of just like key. We design the CPUs that they all, most of them have to rely on. And so it's really about, and since the CPU is kind of the foundational aspect to any, complex electronic, how do we make sure that we're designing that in upfront? Because if you don't, you'll never hit the efficiencies.
Thank you. Perhaps Todd?
Sure. Yeah, the way we approach sustainability, maybe to simplify it, is I'll call it footprint and handprint. Footprint is we've got to build the devices. We use energy, we use water, we generate waste. And so we have a number of initiatives around that. Achieving net zero greenhouse gas emissions, being net positive water, zero waste to landfill. And we're making great progress in those areas as we manufacture. And then on the flip side, we have what I call the handprint, which would be the use of that product. So, to your point, how do we design those products to be much more energy efficient? And then maybe to the point that Barbara made, how do we actually use those products in an application that can then make the world more sustainable? And so I would just echo what Barbara said is our experience has been, we've been at this for literally decades. Our greenhouse gas emissions, if we take that as an example, peaked in 2006. And a little bit of a sneak preview, our corporate responsibility report's coming out next week. our progress in that area, we're approaching an 80% reduction since 2006.
Wow.
Even while growing our manufacturing significantly. So it can be done, and it can be done balancing business, improving our business as well, and leading to profitability.
Are you going to brag about our partnership, or do you want me to?
No, please. I was waiting for the question.
It's also coming. You guys are way ahead of the other companies are, so that's great.
Yes.
No, we'll wait.
Okay. All right.
Suspense.
Suspense, indeed. Kirby maybe is a manufacturing company.
Yeah, I'd love to jump in. I represent the industry that is known as the second worst polluter in the world. So our bar is pretty low, and we're second only to oil and gas. And as Barbara said, what we're doing is reinventing a whole new model for this industry. And we think we can make substantial gains on what happens. But a little bit of figures. In 1960, we were buying 95% of the clothes we were buying were made in the United States. Today, 95% is made offshore, and they're being brought over by these tanker ships. And the tanker ships are just incredibly huge on the pollution side. And part of our goal is to cut that in half and to keep working on not throwing out the overproduction that we have. We believe in sell it, make it, rather than make it and sell it. And that's what our whole model's about. And that model should work in almost any industry. And so that's really what we're about. We are a software company, an information company that is changing the garment industry, being one of the worst polluters. And then we'll move on to other industries with the software that we've developed that runs on your chips. Thank you.
Thank you. And coming to what Barbara alluded to in terms of implementing, sustainable practices and your different companies, maybe I'll leave the floor to you talking about the partnership that Intel and Siemens have put together.
Yeah. So you heard about Intel's commitment to the future. Likewise, Siemens has a commitment. We committed to be carbon neutral by 2030 with the goal to be halfway there by 2020. And we had exceeded that. We're well on our way. The supply chain needs a lot of attention. Our own handprint. Last year, we reported the removal of 190 million metric tons of carbon through our customers' work with the help of our technology. And so, what would it mean if we could work with Intel to green the supply chain? Siemens has a product called Green. It's a blockchain-enabled application that enables us to track and securely manage the carbon information all along a supply chain, so that without violating anyone's IP, without unduly surfacing anything that we shouldn't, within that supply chain there can be good communication and decision-making about the carbon footprint of the products we're producing. And Intel, as a leader in this area, adopting Green has been a massive proof of concept and a vote of confidence. Thank you.
Oh, well, thank you. Siemens has been a partner for us for many, many years. As Barbara mentioned, as a industrial company that makes products for the industrial sector, we've relied on Siemens for literally decades. And so it was a natural partnership. And then when we started talking about sustainability, it's like, what more can we do? And actually, I lead sustainability for Intel. I've been blown away in our discussions with Siemens that we found as we work together, and maybe this is a theme to think about. When it comes to sustainability, literally no one company can solve these issues. They're too big. And so by partnering together, you can unlock all sorts of value. And we found that with Siemens as we sat down, say, okay, now what are you doing? Not only what products do you have to offer, but Siemens, you're a big industrial manufacturer as well. And you've done a number of decarbonization activities. Well, how can we learn from that? And how can we leverage the models that you've already created? So it's just been a tremendous partnership. And I really look forward to what our teams are going to do in this space going forward.
Thank you.
Thank you. And moving on to maybe a little bit about power efficiency that Jason, you mentioned as a Canadian here living in the US now, this is one of the things that I would say struck me the most because, and especially in Quebec, it's all, hydroelectricity. People are used to just leaving the, lights on, washing the dishes and, your clothes at the same time. Doesn't matter because the power is very cheap. It used to be very cheap and affordable and available. This is all changing, obviously. People are a lot more conscious about their footprint and handprint, which I quite like. Now, preparing this panel, Jason had a very telling image about a, perhaps not so distant future where the world would be run by AI and robots while we sit back, enjoy a cup of tea and, watch some TV. And Jason was saying, in that world with the current technology that we have, all would be shut down in less than half an hour because the world would run out of power, which I thought was very telling. And also sort of reassuring if you look at the dystopian version of this. But could you tell a bit more about what's ARM doing to work on power efficiency for the technologies of today and tomorrow, of course?
So I think there's a whole bunch of, there's a significant amount of upcoming innovation on ways to reconfigure and just there's so many different technical aspects that are still, I think, in front of us that are being deployed. I do think, to your point, again, I'm an AI optimist. I think from a pessimist standpoint, when I hear about robots that can take over the world, I'm trying to envision the robot having to stop every half hour and plug in. And it just seems like that would really disrupt the whole, taking over thing. I don't know. But actually, I'd actually love to hear Kirby's view because Kirby's working with robots now, and I'd love to find out how scary are the robots. Do you feel like they're
not at all?
Not at all. Right. Yeah. So anyways, I don't know. No, so but in terms of a little bit what I said before, when the consumption is gonna go up, I think just for data centers, and we haven't even gotten to like edge, or we haven't even talked about self-driving cars and all this. I think right now the estimate is that 1 out of 10 cars will be self-driving by 2030. And that's and that's a pretty significant amount of power. And most of the self-driving cars typically are electric or are expected to be, and then those have to get charged somewhere. And then there's and how do they get charged? How quickly? Where do they get charged? How is the grid infrastructure to put the charging stations in all the right places? There's a little bit of work to do there, I think. So there's from our perspective, the challenge is pretty daunting, but we feel very good about the opportunity of the combination of hardware and, as Barbara said before, software, because there is actually a lot of waste in the system today. So we are optimists that we will solve this.
Great, thanks. And it's good for our eventual peaceful cup of tea with robots and AI. Todd, did you want to add something?
If I could just add to that, and ARM has done outstanding work in this area in energy efficient chips, and I think having been in the industry a while, one of the advantages of that is seeing these cycles come and go as well. And every new technology, there are challenges. There are absolutely challenges that we've got to jump in and work on together, and thus, the innovation theme is critical here. But I also go back to, I'm also very much an optimist. I remember when I'm going to really date myself, but do any of you remember the Palm Pilot? When the Palm Pilot first came out, it was like earth shattering. But there were also all these predictions that your Palm Pilot was going to consume as much power as your refrigerator. And if that was the case, then here's what's going to happen to power consumption. Well, clearly that didn't happen because of innovation in hardware and software. And, now our phones last, 24 hours or whatever it is. And then I remember there were predictions when the cloud computing first started that the data centers were going to grow to like 20% of the world's power consumption. Well, as you said, it's about 3%. Mm-hmm. Now, that didn't just happen by itself. It happened because of the innovation of the engineers, of the workforce that took that on seriously and said, how do we get much more innovative in our hardware and software designs? And I think that's our challenge with AI as well for us as an industry, is how do we collectively really focus on that and drive that innovation and efficiency?
That's great. Thank you. And Kirby, moving on to you, and you've alluded to the systems you've put in place, the software that reduces waste in the garment, apparel, manufacturing sector. Where do you see your technology moving on next after this?
Great question. So I was very fortunate when I moved to the United States. I moved to a place called East Lyme, Connecticut, and it's the dormitory town for Pfizer research, but also for Electric Boat. And all my neighbors were designers of nuclear submarines. And so when we were actually designing our software, we said, not only has it got to be scalable, but it's got to be able to do everything from clothing to nuclear subs. And so we've kind of put that in the back of our mind. So the goal is, as Barbara said, it's developing these new systems, these new models that are very collaborative, and global is a new term for me, but global. And it's not that everything will end up being manufactured over here. It'll be super efficient to do it, part of it over offshore and part of it over here. And I think that's what will happen, is it will merge together into be a fabulous symbiotic relationship.
Thank you. I'm going to add one quick question here before we, wrap up in a few minutes. And Goldie alluded to this in the previous panel, which was fascinating. What would your message be, or your company's message be, to regulators, governments, and I talk from experience, for your companies to thrive into very sort of positive, optimistic environment to drive innovation and more sustainable practices? What would be your one message to governments?
Let's work together. The technology is changing so fast that if you're not actually sitting in the room with technologists, you may not know what needs to be regulated. And likewise, businesses cannot behave as if we know what's happening on the world stage and what's right for the world. Our legislators, our policymakers are in rooms where they're hearing about threats that would never be shared with us. If we can get in the room together, we can find optimal solutions.
I like this. Thank you. Kirby?
Yeah, I agree with Barbara. I think that it's got to be a balance between regulated and unregulated. There's part of me that says, just leave us alone and we'll look after ourselves. But we've seen the results of that. And so we can't be left to our own devices. We need regulation in some areas. So,
Yeah, I think those are both excellent points. I guess I would layer on to that. We have to, and this will sound self-serving, but we have to invest in technology, whatever that is, because it's just going to be critical for any nation to stay at the forefront of the economy from an economic standpoint. But then also when we talk about sustainability, I'm very optimistic when you look at all of the applications where one can use technology to help make the world more efficient, which then in turn lowers the footprint and some of the big challenges that we have. So invest in technology.
Well, going last on this one's tough because all the good stuff's been taken. I guess I would say maybe, hopefully, certainly the long-term orientation. I think Barbara mentioned earlier about how the solutions to these problems typically are not going to be maybe just one election cycle, and that you're going to have to make multi-year investments. So hopefully, like CHIPS Act is one example where I think there's been a lot of progress in the last couple of years. Hopefully that doesn't turn into a political thing and we see slowdowns or whatnot because of, whatever happens. So my hope is core infrastructure, like the stuff that is happening as part of that, is not going to change, and it can't, because I think there's a lot of progress being made, and the challenges aren't going to wait for people to debate it too much longer. And so hopefully we can keep that in mind.
And it's an interesting point: stability and predictability in a very fast changing environment. So it's a bit of a dual, opposing but completing worlds. Maybe in closing, and to leave our audience and our viewers on a positive note, and you've all been very positive. Thank you very much. What would be, looking ahead in a minute, what would you say is the most significant opportunity, looking forward, and how is your company, taking advantage of this? And Jason's point, I'll start with you.
I guess at the risk of repeating myself, I'm excited about what's happening with AI. I do think the efficiency we're getting, we're already seeing it today. I think it's 75% of office applications are already using AI. Most of our phones, most of our devices are already using a fair amount of AI. And the productivity and effectiveness we're getting from that, I think, is absolutely critical to be able to solve some of the issues, that I think we're going to continue to face when it comes to, even things like balancing budgets and all that kind of stuff. Like for us to hit the growth targets that we need, you have to have productivity, and I don't see any way around it. And so that's certainly what we're focused on, and and I feel confident in our ability to help there.
Great. Todd, maybe?
Yeah. If I had to add to that, it would be being the sustainability guy on stage, right? AI for sustainability. So I just think there's so much opportunity. We're implementing a number of things internally. I don't have time to go through all of them, but we have these big industrial plants that use a lot of energy. We've been able to incorporate AI into those systems to make those systems smarter, work better together, and we're seeing efficiencies of 20-30% in terms of reducing the amount of energy that's being used. And you just multiply that over and over and over again, and it's just going to get better as the AI chips and algorithms become much better. So I'm super optimistic about that.
Kirby, maybe one optimistic point?
No, can I go three?
Okay,
First
sure,
one
of
is
course.
innovation,
All right.
technology, and analyzed by AI. That's really going to be the future, I think. So,
Thank you. 3 points, but short and brief.
Yeah.
Thank you. Barbara,
it.
closing?
Yeah. Look at where the real world meets the digital world. I believe we're sensing the development of a whole new tech sector. You're going to hear from Judy Marks in a moment. And, think about the real world and the digital world coming together into the spine of a building. This is happening everywhere. So the Internet of People we've created successfully over the last couple of decades, this next decade is about the Internet of Things, and it's an order of magnitude times bigger than anything we've seen so far. This is the most exciting place to be.
great.
Thank you. It's also very positive, and I'm sure the floor will also agree that we've learned a lot this morning. Thank you very much for your contribution to this very enlightening conversation. Would you please all join me in thanking our panel with a very warm applause? Thank you. Thank you. Thank you.